We actually introduced this whole idea back in the first exam when we talked about scatter plots in chapter 2. So the application problem that we're looking at, we're only going to do this one problem, and then I'll actually do the complete lesson on chapter 10 next time. But this is essentially going to be a problem work from beginning to end, so you know what these problems are going to be like. It says a police department wants to find out if a correlation exists. Correlation means a relationship, but a very specific kind of relationship. If a correlation exists between X equals the number of muggings per night during the warmer months of the year in a particular park not far from downtown, and Y equals the degrees Fahrenheit. They're trying to decide how police duty should be allocated on those nights, and some data points for some nights from the spring and summer past year are given in this table. So basically what we see is that when the temperature was 79, there were 5 muggings. When the temperature was 86, there were 11. When it was 89, there were 12, but then oddly enough, when it was 91, it was back down to 8. So there might be a relationship, but we can't really tell what it is by looking just at the numbers. So what we're going to do is we're going to use the calculator to analyze this relationship. So we're going to take the calculator, we're going to go to Stat, and we're going to enter the number of muggings into list 1 and the temperatures into list 2. So remember, list 1 is the number of muggings. And list 2 is the temperatures. So if you would, please go ahead and enter those into your calculator. Check carefully when you're finished that you, number 1, entered all those numbers correctly and that both of your lists are the same length, because these data are paired. This is paired data. Now there's actually a couple of different ways we could go about getting all this information, but because we're going to go all the way through the hypothesis testing process with this, because this is the last kind of hypothesis test we're going to talk about, what we're going to do is we're going to go back to the Stat button. I'm sorry, not yet. What we first want to do, even though I'm doing this a little bit out of order, it says compute the correlation coefficient. What we want to do first is we want to draw a graph. We need to draw a graph. So what we're going to do is we're going to go to the Y equals menu and use second Y equals, and we're going to turn on plot 1. So you press enter, and then you press enter again to turn it on. You go down arrow, and where it says type, you want to press enter on the very first one, the one that looks like a bunch of little dots.
How does it get to that point?
Second and Y equals. And then hit enter on the very first one. And then from there you go down arrow again, and our X list, which is our list 1, is the number of muggings. And our Y list is list 2, which is the temperature in degrees Fahrenheit. And if you were to use 2 different lists, you just tell it the one you used, list 1 and list 2. And I always leave the mark with the little box instead of the little points because it's just easier to see the little boxes. And then from there, once you've got your screen looking just like mine, we're going to hit the zoom button and choose number 9. So we hit second Y equals, we turn the plot on, we set it up, make sure your screen looks like mine, and then you hit zoom, and we're going to choose option number 9, which says zoom stack. And this is what it shows us. And your screen should look exactly like mine at this point. Has anybody got any problems so far? Okay, what the calculator did when we hit zoom 9 was it looked at this list of numbers, and it looked at this list of numbers, and then it went to the window settings and it set up the window so that you would be able to see those values on it. Go down and choose number 9. There you go. Now the question we have to ask ourselves here is not, do those points line up in a perfectly straight line? Of course they don't. They absolutely do not. But with the exception of this point right here, which seems to be a little bit of an outlier, maybe, the rest of the points do kind of follow an uphill, linear kind of trend. We talked about that back in chapter 2. We talked about positive correlations are when the dots travel uphill, and negative correlations are when they travel downhill. So with the exception of that one potential road data point, let's call it, it does seem to have a linear trend, okay? Since it does seem to have a linear trend with that one exception, what we're going to do is we're going to actually fit a line to that data. And in order to do that, we're going to go back to the Stat button, and we've done this differently in chapter 2 from what I'm going to have you do it now. We're going to go over to the Test menu, and I want you to scroll down to option E, LINREG T-Test. Yours may be F. If you've got an 84, it's probably on F. And your next screen may look just a little bit different too. I'm using the 83, but the 84 has the same option, it's just a little further down the list probably. And when you choose that option, it's going to ask you where your data is. If yours is in list 1 and list 2, like mine is, you just leave that alone. And once again, since we don't have a frequency distribution, we're just going to leave frequency as equal to 1. In this particular case, we're going to choose the not equals to option. Okay? We're going to choose the not equals to option. Without worrying about what either one of those are, we're just going to say they're not 0. And then the next option says REGEQ. What it's doing is it's asking you where would you like for it to put the line of best fit so that it can graph it in your calculator. So where it says REGEQ, I want you to hit your vars key. It's right next to clear. Right arrow to the Y vars key. And hit enter twice. And that should copy Y1 into that location. Now we're going to have time to practice that. I know you're not going to get this down pat the first time through.
Where do we push after vars?
Excuse me?
Where do we push after?
Right arrow to Y vars. And then hit enter 2 times. And your screen should look like mine now. There's your steps. And we only have one option on the last one. We don't get to draw pictures this time. We're going to calculate. Okay? So if your screen's set up like mine, we're going to hit enter to calculate. It's going to come back and it's going to give us a whole bunch of information. More than it can show us on that first page. What it's giving us is a t-value because it's a t-test. But it's also giving us a p-value. Now I'm going all the way to the bottom on this because we're not even going to answer the other questions until we answer this last one. The last one says, if your significance level is alpha 0.01, is the value of your correlation coefficient significant? And the way we set the test up, we were saying that it was not significant. Our p-value is 0.04. everybody see the p-value? 0.04327242228. This works exactly the same way as any other hypothesis test would. HO says there is no relationship between muggings and temperature. H1 says there is a relationship. Okay. HO says there is no relationship. H1 says there is a relationship.
Does HO always say there's no relationship?
HO always says there is no relationship or differences. There is none. Okay? And then H1 says yes, there is. When do we reject HO?
When P is smaller than alpha.
Okay, when P is smaller than alpha. Which is smaller.
Alpha.
Alpha.
So P is greater than alpha.
So you exact null.
That's right.
So there is a relationship.
So we do not reject HO. And we don't have any evidence that there's a relationship between muggings and temperature at this point. Okay? Even though the data sort of looked like there might be. Let's go back and look at that scatter plot again. Now there's the line going through the data that the calculator fit. And that line does come fairly close to all of the points except which one?
Top.
That outlier up there.
Yeah.
Now, if I hit my trace, there it is. That night that it was 91 degrees and there were only 8 muggings. Other than that, it looks like that actually the hotter it is, the more muggings there were in the park, right? Except for that one. That one seems to be a problem. That one is called an outlier. We don't have a rule or a test to figure out whether or not it's an outlier. The only thing we can do to find out if there's an outlier, or if we think there's an outlier, would be actually to go look at the scatter plot and see one point that falls way out of line from the others. Okay? That outlier has a really, really strong influence on how this came out. Okay? So we're going to work this problem, even though there is not a significant relationship. We're going to go back and answer the rest of the questions. And in order to do that, I'm going to have to run through my test again so that I can see all the information. We're going to go back up to the top. And we're going to pretend that we don't know the answer to the end of it. So question A says compute the correlation coefficient. The correlation coefficient is R. So you have to scroll down on that screen to find the value of R. And R is 0.72. .722, since it says to 3 decimal places.
How do you get back to it on the calculator?
You go back to stat, you go back down to that test, and then just arrow all the way down to the bottom and hit calculate again. Now, some things that you'll know about are after tomorrow or after Wednesday. R is always between 0 and 1. Or, excuse me, always between -1 and 1. That's one of the conditions of R. The closer R is to either -1 or to +1, the stronger the relationship is between your set of data. Our R value is actually closer to +1 than it is to 0. 0 means there would be no relationship, okay, which is what our HO said, there is no relationship. But our R actually is closer to 1 than it was to 0. The thing is, what's making R be 0.72 instead of being a lot closer to 1 than that is that outlier. So I want you to remember that. The next question says compute the coefficient of determination. The coefficient of determination is literally the value of R squared. And we don't have to square it because your calculator's already squared it for you. The coefficient of determination is 0.521. And we always translate it into a percentage. We always state it as a percentage. Now, since R squared is literally the value of R squared, if R is negative, R is going to be positive. R squared is going to be positive. If R is positive, R squared is going to be positive. If R is 0, then R squared is going to be 0. So that means that R squared can only go from 0 to 1. Even though R can go down to -1 and up to +1, R squared is going to be somewhere between 0 and 1, or 0% and 100%. Okay? And we will talk next class about what R squared actually tells you. Then it says find the line of best fit for the data. Hit your Y equals button. That's the line of best fit. Now we can round that to 2 decimal places because it says we can. What I'm going to do before I even try to write it down is I'm going to go over here and try to round it to 2 decimal places so that I can write it down more easily. So 75.985 would become 75.99, and then I would just drop the rest of that number. And then 1.082, that would remain 1.08, and I would drop the rest of that number. Now don't get too happy doing this or you'll wind up deleting your X. So our line of best fit for this data is Y equals 75.99 plus 1.08 times X. And keep in mind that Y represents the temperature. And X represents the number of muggings. So that's actually the equation of that line that you see when you hit graph. That's that line being graphed right there. So our next question says, if there were 10 muggings, what would you predict the temperature would be that night? That means take your line of best fit and plug in 10 for X. And you get 86.79. So what that means is, if there were 10 muggings, the temperature would be about, because you can't say it's exact, it would be about 86.8 degrees. That's what that line is for, is to predict. You can take an X value and predict what Y would be.
I think I missed that part. So how did you, like, where did you put in the 75.99?
I went back to the home screen. You hit second and mode to get back here. Now we don't need the calculator for any of the rest of this. When E asks us about what percentage of variation in the temperature can be explained by the line of best fit, it's taking us back to question B. And that percentage is 52.1%. So the answer to E is connected to B. The answer to F is connected to E. What percentage of the variation in temperature is unexplained? Well, if 52.1% is explained, then 47.9% of the variation in temperature is not explained by the line of best fit. Now what that means in practical purposes is that 47.9% of the variation in temperature isn't explained by the number of muggings that took place. There's something else. What actually would make more sense if we were trying to talk about how much of the variation in the number of muggings is based on temperature. And you can actually switch those two around and answer the same questions. You can't control the temperature, but you could control the number of muggings, because you could actually assign more or fewer police officers. Okay? So we've answered all these questions, and we're seeing really in these last two that because of that one lousy little point, even though it does look like there ought to be a better relationship, it's about a 50-50 deal on whether or not temperature has anything to do with how many muggings take place. So what we're going to do is we're going to do one last thing and see how some things change. We're going to go back to the data. And we're going to drop out 1 point. We're going to drop out that point that said when the temperature was 91 degrees, there were 8 muggings. So we're actually going to toss out one data value, one data pair. I'm going to toss out this one. Okay? Here's a brand new clean worksheet.
It's just a need.
The only difference of what I'm going to do now, what we did before, is remember we've left out the outlier. So we're doing the same thing we did before. So I'm going to go back to stat, over to the test. Down to the linear regression t-test with that 1 point gone. My data is in list 1 and list 2. The frequency is 1. Nothing else changed. I left everything the same. I'm just going to recalculate all those numbers. What does it say the p-value is now? How does the sign go between p and alpha now?
P is less than alpha.
Ah, p is less than alpha. soldier out of the way. It says there is evidence of a relationship between temperature and muggings. Okay? Now, since I changed the scatter plot, I'm going to change back to zoom 9 again, so that it will refit to the new set of data. You see there's no outlier. How much better does that line actually kind of fit with those points?
Oh,
Looks like it fits a lot better. That means when we go back and do all these things, we're going to have different numbers. So it says now R is equal to 0.92. That's a lot closer to a positive 1 than the 0.74 that we looked at before. And it says R squared is 85.8%. Which, coming down here to question E, says 85.8% of the variation in temperature can be explained by the line of best fit. Which means (100 minus 85.8% would be 14.2%. Is not explained. Which is a lot different. And the line of best fit actually changed as well. The line of best fit is now (75.35) plus 1.05 times x. And y again is temperature. And x is the number of muggings. And if there were 10 muggings, then the temperature probably would be about 85.4 degrees. Okay? So this is the kind of problems that we can work in Chapter 10. And it goes right along, as you see here at the bottom with hypothesis testing, goes right along with everything that we've done in Chapter 8 and Chapter 9. Okay? The main things you're going to need to know how to do is how to come up with a regression equation, how to figure out what R is, how to figure out what R squared is, and explain some of these things, be able to make predictions. So we're going to talk about that more next time. But unless y'all have some questions or anything, we're finished with any new material today. And I will give you your take-home test on Wednesday. And then you'll have until Monday to get it done. If I have any questions about anything else.
How long?
Excuse me?
About how long will it take on test?
I'll probably actually give you the same kind of a test that I would give you in class. But the reason that I'm going to give you it as a take-home is because it takes so long to set up the problem. So you can expect it to probably last a couple hours, take you about maybe 2 or 3 hours to do. Okay? And you can expect there to be kind of one of every kind of problem that we've done. Okay?
When is it again? The take-home test?
I'm going to give it out on Wednesday. It'll be due on Monday.
Are you gonna post the post-test for yet?
I am. I just haven't made it up yet. I'll go in and calculate it.
Is there one for the take-home test? Like, will there be a post-test?
There won't be for the take-home test, no. I may do a little something in class, like, match this problem up to which kind of a test it is or something. But there won't be the analysis like there usually is, because I won't be able to have it graded in time.
Do you want us to submit the Muggings Worksheet?
No, it's just part of your notes. I did want to tell you, there is an extra credit opportunity that I did post. If you look in Show Me, it's about the Schindler exhibit. I know probably everybody can't attend that, but if you can attend that, I'll let you, that is an extra credit activity. Check Show Me. Y'all free to go?